Hello dear students. So we are solving problems on lines. Let us look into this problem. A line AB 80 millimeter long is inclined to HP at 30 degree and inclined to VP at 45 degree. So he has given the true length 80 millimeter long and he has given the true inclinations with respect to HP 30 degree, that is angle psi, with respect to VP, that is theta 45 degree. Draw its top and front views of a line and determine their lengths, and also find the perpendicular distance of NB from both the HP and VP. This is what he has given in the problem. So let us write down the true length. It is given in the problem as 80 millimeter. Next, he has given HP inclination, that is VC in VP. We call it as angle psi. It is given as 30 degree. And with respect to VP, that is theta, so this is theta will comes in VP, angle psi comes in HP, angle psi, it is 45 degree. And draw its top and front views, what he has said, and nothing else. That means the line starts from the XY line itself, because end A point is not mentioned in the problem. Okay, so let us construct the XY line first. Let me construct the XY line here. Right, so hope this much is sufficient. Let us locate the quadrant. Above HP as above XY line as VP, below XY line as a HP. Now let us measure the true position of a line from a common point. Okay, so HP inclination that we can see in VP is given as 30 degree. So let me mark that 30 degree first. So here is the 30 degree. Okay, so the true length is given as 80 millimeter. So better you draw the length of a line on 30 degree first, then you measure the length. Okay, next he is given 45 degree. So let us get into this. Okay, let us get into this 45 degree here. Okay, let me draw the line. Let us not worry about the length of a line now. Now I am going to mark the dimensions 80 millimeter both in front and top view, because that is a true length what he has given in the problem. So let me mark 80 millimeter here. This is 80 millimeter length, and here also I am going to measure 80 millimeter. So this is A dash and this is A, the same point, but here we have to write as B1 dash as well as locus of B in front view. The XY line itself is locus of A in front view as well as locus of A in top view. Now we have measured 80 millimeter length, so let me draw a locus here also. So write it here, locus of B in top view. So let us be B1, this is B1. So let me draw the angular dimension. $30 degree. So here it is 45 degree. So once you done that, the next thing here is I need to measure the true length in only one of the side. So let me measure it on the front view itself. Let us not worry about it. So let me do the dimension there itself. So try to always use the markings in the inches side so that you can get a parallel lines to the true length. It's better always. So let me draw somewhere else here so that the view length will not be get disturbed. So slightly you can make it darker if you want. Right, so that's about the true length. Now just I need to get the view length. It is the same steps what we followed, that is drawing the projection of locus B to the opposite locus, that is locus of A in the opposite plane, then measuring the distance, that is AB2, and drawing an arc such that it bisects the locus of B in the same plane, that is what we are considering is the top view. Okay, so once you draw that, just draw the true length, just draw the apparent length, sorry, just draw the apparent length and name this one as B1 dash. So once you find the top view length, getting the front view length is very simple. Just draw a vertical end projector or vertical line, nothing but a end projector. As I told you, end projector is nothing but the horizontal distance measured parallel to XY line between the end points of a view length, end points of a view length. It may be front view length or a top view length, that is A dash and B dash, A1 dash and B1 dash. So what is said in the problem is measure perpendicular distances of NB from both HP as well as VP. So for that purpose, let me construct a vertical line and let me parallelly expand the locus of B and let me dimension it later. Okay, now if you can measure, this is the perpendicular distance measured with respect to end B, with respect to end B. So let me measure the distance. Better always measure from the object. There might be a slight variation. This is 40 millimeter and here it is 55 millimeter. And also find the apparent inclinations. Since the data is given almost the same of the previous problem, so it will be the remain same, say 45 degree is exactly 45 degree it's showing. So let me draw that. This one has 45 degree and here must be around 55 degree. Let us hope that is same. Yes, it is coming around 54 degrees. Let us not worry about it. It is 55 degree. So the solution for the given problem is alpha is 45 degree, beta is 55 degree, and perpendicular distances of end A, end B is 40 mm above HP and 55 mm front of VP. This is the answer for the current problem. Thank you, dear students.